Let's look at the solution of modern maths bites. Find the number of squares in the following figure. You have this figure here. I'm naming the vertices A, B, C, D. The center point is Z. And these 4 points, midpoints of the 4 squares on the outside, as M, N, O, and P. Now see, for the large square ABCD, you of course has ABCD as one square. Then you also have AMZP, you have BMZN, you have COZN, and you have DOZP. Or altogether, for one large square, you get 5 subsquares. You get 5 subsquares. Using the same idea, you can go ahead and check. Here also you will get 5. Here also you will get 5. So altogether, how many squares in the figure? Answer will be 15. 5 per every large square. Next, how many odd 4-digit natural numbers have the digit 5 exactly once? Okay. So 4-digit natural number, and I need 5 exactly once. There will be 4 cases. 5 can come at any of these spots. So let's say 5 was here and here and here and here. This also has to be an odd number. So at the last spot, you need to have one of the other 4 odd numbers, because digit 5 should come exactly once. And the remaining 2 spots can be filled up by any digits. See, 5 has to come exactly once. That does not mean the other digits cannot repeat. So apart from 5, these 2 blanks can have any digit. So this can come here 9 times or 9 times, or altogether we get 9 into 9 into 4, 81 into 4. So 324 cases from here. In the second case, again, the last spot will be filled up in 4 ways. But now the leading spot, it cannot have 5. It cannot have 0. So this will be filled up in 8 ways. So 8, 9, and 4. So this will add up to how much? 8 into 9 is 72. 72 into 4 is 288. Okay, for the third case again, last spot in 4 ways, leading spot in 8 ways, and the first spot in, second spot in 9 ways. So 8 into 9 into 4, we again get 288. For the last case, the good thing is this number is already odd. So all I need to do is ensure that the first digit is not a 0 or a 5, and the rest is fine. So here I will get 9 into 9 into 8. So 648. So if I add these 4 cases up, I should get my final answer. I get 8, 8, 8, 24. So plus 4 is 8. 2 carried over. 10, 10, 4. 2 carried over. 6, 2, 2, 10. Plus 5, 15. So the final answer here is going to be 1548. Next, on 1 has 8 black marbles and 7 white marbles. On 2 has 9 black marbles and 15 white marbles. One marble is drawn at random from urn 1 and put into urn 2. Next, one marble is drawn from urn 2. What is the probability that the marble drawn from urn 2 was of the same color as that drawn from urn 1? Okay. So from urn 1, if I get black from urn 1, I should get black from urn 2. Or if I get white from urn 1, I should get white from urn 2. So black from urn 1 is 8 by 15 into, now when that black comes here, I will have 10 black marbles out of 25 marbles in urn 2. This is the first case. In the second one, I will have 7 by 15 into 16 by 25. Okay, so this gives me 80 and 112. So I will have 192 in total. 15 into 25 is 400 minus 25. So 375. They have 3 in common. So I will cancel that out to get 64 by 125. Or option B will be the final answer. Next, 40 people prefer A, 50 people prefer B, and 80 people prefer C. A and B are preferred by 30, B and C are preferred by 40, and A and C are preferred by 30. Find the minimum number of people surveyed. Okay. Case for maxima, minima in Venn diagrams. Set A has 40 people, set B has 50 people, set C has 80 people. A and B are preferred by 30. So this region here is 30. These two regions together are 30. B and C are preferred by 40. So these two regions are 40. B and C are preferred by, A and C are preferred by 30. These two regions here are 30. Now we are looking for minimum number of people surveyed. Okay. So if I take this central value as X, this here will be 30 minus X. This here will be 40 minus X. This here will be 30 minus X. And this region here, because this entire circle is 40, 30, 30. So this will be X minus 20, 30, 40, 70. So this will also be X minus 20, 30, 40, 70, 80. So this here will be X plus 10. Now, total count of people would be, see, the set C entirely plus these three regions. So X, X minus X. So you will have X extra and minus 20 plus 30 minus 10. We know 80 people liked C. So 80 minus 10. Final count of people is a total of 70 plus X. Final count of people is 70 plus X. Additionally, each of these regions represent a count of people, and count of people can only be a whole number. So can you see the minimum possible value that X can take? Minimum possible value that X can take has to be 20. Worst case scenario would be people who have only A, people who prefer only A should be 0, or people who prefer B, only B, should be 0. So X has to at least be 20. So the min value of X is 20. So the min value of total count of people surveyed will be 90. So how would it look like? It would look like something like this: 20, 10, 10, 20, 30, 0, and 0. This would be the final distribution. Minimum number of people surveyed will be 90. Last question: in how many different ways can P into Q different objects be divided into P groups, all groups having the same number of objects? Now, this is a classic theoretical question. In fact, the more popular version of this is when you have 52 cards. When you have 52 cards and you have to divide it into 4 groups. There is an extra variation where you have to divide it to 4 people, but here you have to divide it into 4 groups. And in this case, how you divide it into 4 groups is 52C3, sorry, 13. Let me first also do P into Q should be 52. I have to divide it to 4 groups. So P is 4 and Q is 13. So 52C13 into 39C13 into 26C13, and the last 13 cards left will go to the last person. So now it will break down into 52 factorial by 13 factorial, 39 factorial into 39 factorial, 13 factorial, 26 factorial into 26 factorial by 13 factorial, 13 factorial. So gone, 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 gone. And finally, we are left with this expression: 52 factorial by 13 factorial raised to the power 4. The problem here is, let's say the first person, the group of cards that he had, the first group is all spades. The next group is all diamonds. The next group is all clubs, and the last group is all hearts. but you don't know which was the first group. These are not ordered groupings. Because these are not ordered groupings, you also need to ensure, because all these groups have identical sizes, you also need to divide this entire thing by 1 by 4 factorial, and this is going to be your final result. If you know this 52 cards 4 groups work, not 2 people, just 4 groups, then you would know this expression, how this comes into being. Now all we have to do is simply go and check which option we are getting the similar work in. This says 52 factorial by 4 factorial raised to the power 4 into 4 factorial. No, this is 52 factorial by 4 factorial raised to the power 4 into 13 factorial. No, this is 52 factorial by 13 factorial raised to the power 4 into 4 factorial. Yes, this is precisely the expression that we are also reaching. So this should be the answer. For peace of mind, we will also look at the last one. 52 factorial by 13 factorial raised to the power 13 into 13 factorial. What nonsense. Okay, this is also not the answer. This has to be the answer. Because as in I have gone ahead and done the 52 cards thing because that is a very, very standard basic fundamental question, and it gets most of you who are preparing for the second or the subsequent time you would have seen it, probably will help you more. That will be all for this episode. Hopefully you learned something. Okay, bye.